Algebra 2 honors. Here we go. Yesterday we looked at 1, 1, 1, 2, did some number sense, order operations, and then some simplifying. Today we're going to take that a little further. We're going to solve linear equations. We've done that a lot in the past, but we're going to make sure we've mastered that. The golden rule of algebra: do onto one side what you do to the other. It's the equality. Whatever you do to one side, do the other. So to solve means to isolate the variable, get the variable by itself is another way of saying that. To isolate it, we want to do the inverse or opposite operation. If you remember, the additive inverse was the opposite operation from yesterday. And so state the opposite. So the opposite of adding 3, pretty simple, would just be to subtract 3. Opposite of subtracting 13 would be to add 13. It undoes what was occurring. Some of the double signs, you may want to change a minus and negative to what it actually means. A minus and negative is the same thing as plus 5. So then the inverse of that would be minus 5, or the opposite. So be careful with the double signs. Opposite of multiplying by 6 would be to divide by 6. It undoes multiplication. Opposite of dividing by 2 would be to multiply by 2. Then the opposite of multiply by 2/3. A lot of students will say we want to divide by 2/3. But we don't divide by fractions. We need to remember, recall for fractions. How do you divide by fractions? First thing we always do is we actually multiply by the inverse or the reciprocal. So instead of multiplying by 2/3, we want to multiply by 3/2. That'll undo it. So this is what we're going to look for when we see fractions. So we're going to solve a little different. I'm going to take some basic ones. This equation, x plus 5 equals 7. You know how to solve that, or a lot of you know the answer. What this notation is over here is asking you to show me some work. So I want to see your thought process to go through. And so on the left-hand column, you're going to write the order of operation, what's happening to the problem. On the right-hand side of the column, right column, you're going to do the order of solving, or the opposite. So for this problem, when you look on the left-hand side, what is actually occurring to x? That's your thought process. What is happening to x? So in that problem, we are adding a 5. That's all that's happening to x. We're adding 5. So in your thought process, that's, you know what's happening to x. So then on the other side, you'd write the opposite. We are going to subtract 5. Let's see if I can make an S and a 5 look a little different. So the right hand side tells you what to do to both sides. Now when you are solving, you want to have the equal sign, the column vertically lined up with the other equal signs. The left hand side, the right hand side, you're going to stay underneath it, and you kind of funnel the problem down. So we're going to subtract 5 to both sides. Subtract 5 to both sides. Then we're going to have x, 7 minus 5 is 2. So another problem here has more than one step, a multi-step problem. And when you write the left column, you say what's happening to be, you use the order of operations. So what's happening to be there, we would have to multiply before we subtract. So we say the first thing happening to be is we are multiplying by 2. The next thing that is happening to be would be to subtract 4. So those are two things that are happening to be. Now we can write what the inverse, the opposite, is. We want to divide by 2 here, because that's the opposite of multiplying 2. Then subtracting 4, the opposite would be to add 4. So now we know that the left column is what's happening to the variable. The right column is what we do to solve it. So a way of checking, do you know what your thought process on what's occurring. So we want to add 4 to both sides. So we write the equation, so 2b equals 20. A lot of students are asked to show work, but sometimes they don't show because they don't know how to show work. So this is kind of showing you what to do to show work. The next thing we want to do is divide by 2 to both sides. So both sides, divide by 2, divide by 2. Just simplify the side, we get b. Why do we get b there? What is the math that gives us b here? Because 2 divided by 2 is 1. And then 20 over 2 is 10. So that's a different way of solving, a way of your seeing your thought process and showing me your work. Some quick ones to solve. opposite. Here, just make sure that you see that you have to include the sign with the number. When a number is touching a variable, it's actually multiplying. So using that notation, we are actually multiplying by a -2. So the opposite would be divide by a -2. We still keep the sign. We are changing the operation. So divide by -2, divide by -2. So we have x equals -6. Over here, what's happening, it doesn't matter what side w is on, you still want to isolate it. So the opposite would be add 4, watch your mental math, watch your signs. We have more negatives, so we have negatives left over. So -2. Here we are dividing by a negative. Again, the operation is dividing. We're not subtracting, even though it's a -5. We're not subtracting. We're dividing by a -5. So the opposite will be to multiply by a -5. Keep the sign, change the operation. So then we would get -20 equals r if you do that to both sides. Skip it down here, watch the double signs a little bit. If you want to rewrite it first, minus a negative as plus, then you can go through to solve the problem. That might help some of you out, or make sure that catch you from making some most simple mistakes. Let's do 6 here. So we still have 1/2 b. I'm going to rewrite these double signs. Plus a -2 is the same thing as just -2. Those are equivalent, so it doesn't matter how you write that. Let's add 2 to both sides. When you solve, you go the opposite of the order operation. So adding and subtracting is usually last. When you solve, it's actually first. You want to get rid of that first. So we have 1/2 b equals 5. Now, how to get rid of the half? It goes back to what we were just talking about. The opposite, or the inverse of multiplying by a fraction, is multiplying both sides by the reciprocal, which is 2/1 or 2. You multiply this side by 2/1. So 2/1 and 1/2, those are multiplicative inverses or reciprocals, so they are equal to 1. So we have b is 10. So good use of some of the terminology from the previous section. So we can try solving this one. When you have a more complicated one here, what's actually occurring to x, there's many things occurring to x. And so to help us out, we can use some of yesterday's lesson. We can actually follow the steps of simplifying. So when we look at our notes here, we can look at distribute, remove grouping, and combine like terms. That's what we talked about yesterday. That's what you do to just simplify. So you really want to simplify each side. And so if you look at the left-hand side here, just simplify this first. So that means we have to distribute, and then we have to combine like terms. So -4x is still part of the problem. We still have it equal 8. Keep the equation true. Now combine like terms, so 2x minus 4x, those are on the same side. So I can combine them to be -2x plus 14. That equals 8 still. Now we can go through the same thing we were just talking about, the inverse of addition subtraction, and eliminate the addition subtraction. So we're going to -14 to both sides. So we have a -2x equals -6. And then we can undo the multiplication, and divide by -2 to both sides. So x is 3. The last thing you can do is actually take your solution here. You could plug it back in for the x's in the original problem to check that you are correct, checking your answer. So 2 problems here. I'm actually going to move on for, make this a quick one, lesson. I want you to try this problem and turn it in. Actually, we can go through this because this one is a little different. We have n on both sides, so that's a little bit different. So we can first simplify each side. So on the left hand side, I'm going to distribute. So that's 2n plus 4 equals n plus 16. Now I still need to combine on the left hand side. I can combine these n's, so that's really 3n. Now we have n's on both sides, so we haven't talked about that. There was some steps in the previous slide. I think I missed that. So using addition and subtraction to eliminate the variables from one side. So that's really what we want to do for this problem. We want to get rid of the variables from one side. So on the right hand side here, we typically choose the smallest amount of them. That way it stays positive, but it does not matter. We are going to get rid of this n. So to get rid of it, again, it's that inverse. That's a positive 1, so we want to subtract 1 to make that become 0. Whatever you do to one side, you do to the other. So we have 2n plus 4 when we evaluate this equals 16. The rest of the problem is what we've been doing so far. We're going to undo the addition. We're going to subtract there. So it's 12, and then we can divide by 2. So we have n is 6. So there's the solution. So again, try number 1 here. Again, one problem we'll look at at the beginning of class. Have you turn in, check to see how you're doing, show work. Show your work. Look at all the work that I showed. Easy to follow. Make sure I'm correct. Okay, a little more complicated. We're going to deal with some fractions here. How would you solve this? Using the same steps, we would add 1/4 to both sides. So what is a half plus a fourth? Pretty easy. Keeping it easy. But reminding you to add fractions. We know this. If I had half of it, I'm getting ahead of myself. If we had half a pizza and a quarter of pizza, we know we have 3/4 of pizza. But to add fractions, we need to have common denominators. So 1/2, 2/4 are equivalent. That goes back to how to add fractions. Some of you might be sighing at me, but you want to recall that. 2/3 x. How do we get rid of this 2/3? The way to get rid of it is by multiplying by the reciprocal. So 3/2. Do it to both sides. And then we get to, here's multiplicative inverse or reciprocals is 1. So we get x there. Now we got to review how to multiply. When I look at multiplying fractions, I would look to see if I can reduce anything from the numerators and the denominators. And I can't here. So then we just multiply straight across. 3 times 3 would be 9. 4 times 2 is 8. So we have 9/8 or 1 1/8. So that worked fine. Not too hard. The fractions were really simple for you. That might become... Oh, I lost my... There it is. This works, but there's an easier way. So let's talk about another method when the fractions get more difficult, and that's using a multiplying by a common denominator. So when we see the problem, we see there's fractions, multiple fractions, especially when you're adding and subtracting constants that are fractions. You want to look at the denominators. We have a 3, a 4, and a 2. And we say, what is the common denominator? Which is also saying the least common multiple of those denominators, 3, 4, and 2. The first number that 3, 4, and 2 all go into. So you can look at multiples of 3, 3, 6, 9, 12, 4, and then look for 4, 4, 8, 12, and then 2, 2, 4, 6, 8, and 10, 12. So you can see that 12 is a common multiple. So you multiply everything by 12, multiply both sides by 12, it will actually get rid or reduce out all of your denominators, all your fractions. So when you multiply this, this has to be distributed through here. So 12 times 2/3. Let's just do that problem right here. 12 over 1 times 2 over 3. Again, when I multiply fractions, I look to see what can I reduce. Well, 12 and 3. 12 divided by 3. 3 goes into 12 4 times. So those reduce to 4. Then I can multiply straight across. 4 times 2 is 8. So if I multiply 12 times 2/3, I'm going to get 8, and I still have x, 8x. If I multiply 12 times 1/4, a fourth of a 12th. A fourth of 12 is 3, or 12 divided by 4. And then another easy one, half of 12 is 6, or 12 divided by 2 is 6. Now I no longer have fractions. Makes solving the equation much simpler, quicker for most of us. It's the biggest reason. And then we divide by 8, so our answer is still 9/8 or 1 and an 8 as a mixed number. So fractions, they're okay. I'm going to throw them at you, be ready. So here's another one for you to try, similar. Try using a common multiple or a LCD, least common denominator, to eliminate the fractions to start, just to practice that, and that's the second problem for you to come in with for us to talk about at the beginning of the day. So here we go. We did solving linear equations today. Here's what we have tomorrow. I'll probably be combining these for one lesson, how to rewrite equations, so solve linear equations for y, solve formulas for a given variable. So you have multiple variables, how can we get one isolated? And then problem solving. The word problems you guys see, we're going to start tackling those, and we're going to work on those every day in class for a while, hopefully. So good night until tomorrow. Make sure you have 2 problems done. If you have questions, throw them on YouTube and I'll try to respond.